Alright, so today we're going to take a look at an introduction to logs. So the first thing I want you to do is take a look at this screen here, and I want you to pause it and see if you can notice any of the patterns. So take a look at it for a minute and then turn it back on. So hopefully you've noticed here, this is kind of like an exponent rewritten. This is 2 to the third equals 8, 2 to the fifth equals 32, 3 squared equals 9, 3 to the fourth equals 81, and 5 squared equals 25. So now we're asked to fill some of these in. So we're kind of like saying, well, 2 to what power gives us 16? Well, that would be 4. 6 to what power gives us 36? Well, that's 2. 5 cubed, well, that is 125. 2 to the negative 1, well, that's 1 over 2 to the first, so that would be 1/2. And then this last column, 10 to what power gives you 1 over 1,000? Well, 10^3 gives you 1,000, but it's in the denominator, so -3. What number squared gives you 81? So that's 9. What number to the fourth gives you 81? 3. And 16 to the 3 over 2. Well, that's 16 to the half. And then we cube it, so 4 cubed is 64. So what we looked at here, it has power, and they're related to exponents. And the mathematical word for this is logs. So the next thing we're going to do is take a look at this. And so exponential form, we have b to the x equals a, where b is the base of the exponent. In log form, we can write that same thing, and we call it log base b of a equals x. So you'll notice here, and I always will say this, the base of our log is the same as the base of our exponent. So on this next page, we're going to convert back and forth between log form and exponential form. And if its base isn't written, the base is automatically a 10. It's called the common log. So if we take a look at this first row here, there's no base on the first one, and then we have a base of 5, a base of 7. So in exponential form, base of 5 to the power of x equals 625. This one would be 7 to the power of x equals 49. This first one, there is no base, so it's kind of like saying there's a tiny subscript is 10 there. So 10 to the x equals 1,000. And then we're asked to go the other way, rewrite it in log form. So log, the base of our exponent is the base of our log, so base 10 of 0.001 equals x. But you won't see it with log base 10. You'll just see it as log of 0.001 equals x. This next one, log base 5 of 100 equals x. Then we have log base 35 of 8 equals x. And this is in log form for exponential form. So 6 to the x equals 1. We need to write this one in log form. So log base 0.4 of 5 equals our exponent of x. And this last one, well, there's no base, so we assume it's a 10. So 10 to the y power equals x plus 2.